Okay, before we start chapter 6, I think one of the things we want to be doing is just making sure we're ready for the content. So your Blackline Master 6-1 is the worksheet you should have right now if you're looking at this video. I'm just going to go over some of the questions that I think you should highlight and just come in for the next lesson having practiced these, and if you have any questions, come see me in class. So for the first question, this is just about patterning. So this chapter is all about different types of functions and how they pattern out as far as numbers. This example in number 1 offers some letter patterns as well as some with exponents. So I think what you want to just do is make sure that in the first 2 parts, A and B, you could recognize that, for example, here there's a ratio and it's doubling. That should be obvious. Likewise in part B, not a ratio. We're not multiplying anything consistently. However, if we look, we're adding 1 between the first 2 values, then 2, then 2 again, then 4, then 2. So it's difficult to determine the pattern there. Or if you look at that one, there might be a couple possible answers for that. So I'll leave that one with you. Number 2, this again, we've looked at functions this semester, function notation in particular, and we're just looking at making sure you remember how to input values wherever you see a variable. Would just point out here, there seems to be a bit of a mistake. I would probably think most of you would have caught that, but if our input letter variable is t, we should have t on the right side of that equation. So just make sure you're able to substitute both numerical values, as in parts A and C, as well as expressions which B and D offer you. That might be a little bit new in parts B and D, so let me just demonstrate one example. For part B, we're entering in not a number, but rather an expression using our variable. So rather than replacing t with the value, we're going to put in 3t plus 5, where we see t, and then we're going to simplify that. So we just need to distribute this bracket here and subtract 7 to finish that one off. So let's keep going with number 3. Again, familiar function equation. This is a parabolic function, so we're looking at quadratics. And again, here you're just putting in mostly numerical values, except with part D. You might want to evaluate it for an expression in x. Number 4, you might be wondering that a little bit of a switch of function types here. We're looking at an exponential function, and in this case we know that because the variable is in the exponent as indicated there. So just remember that this is also nonlinear, and you may not have studied this type of function extensively in the past, so have some patience with it. I might suggest you practice all of number 4, put in the values, and make sure you're able to calculate those with your calculator. Just be sure to watch for things like order of operations. We have to evaluate the exponent first by subtracting 1 from the x number. Then we apply that to base 4. Then we multiply. So just remember, BEDMAS applies to this question, and you'll be okay. I'll work out one problem here just to give you a head start. So for C, we're putting in 0. This one's fairly straightforward. Nope. We just correct that. 4 is our base, and we end up with an exponent of -1. And you may have to go and look at the prerequisite skills section for exponent laws. Just refresh yourself here with exponent laws. Those are equivalent to reciprocals. So 4 to the -1 is equivalent to 1 over 4 to the +1, which is a quarter. Multiply that by 3 and we would have our answer, which would be 3 over 4. Okay. Number 5, again, we're sketching these different types of functions here. We work quite a bit in the class with the graphing calculator, so linear, exponential, quadratic, and another quadratic in part D. So those ones should be familiar to us at this point, maybe with the exception of part B. I would just challenge you to try a table of values for part B of number 5 here, and just if you're looking for a suggested domain, I would try some in the negatives and work your way through. So maybe something like -2 all the way up to +2 as a suggested domain for that one. Alright, so let's continue into the section called solving equations. I would think that most of you would have no problem with the ones I'm going to check off. Watch for this one, you have to be careful to, in part C, clear your fractions. And you're going to want to just make sure you're comfortable solving different types of equations for this chapter. Part D as well. Some of you might look at that and think, well, okay, common denominator, that might be a good approach to start off with. Lowest common denominator would probably help there. And we're thinking 12 is the lowest common multiple for 3 and 4. So we make equivalent fractions. That would produce 4x over 12, 3x over 12, and that's equal to 2. So when we combine, we're going to end up with 1x over 12 equals 2. And we can clear our fractions from that point, and I'm sure you can handle it for the last step on your own. Number 7, just remembering, converting from percent to a decimal, we want to do what? You should be thinking divide by 100. So just be clear on how to work with percents and decimals. And when you're seeing the word of in an expression, that always equates to multiplication. So just remember that. Of, you want to produce multiplication operation. So I'm going to switch over to the other half of the worksheet, going up to number 8. These are just fraction questions, and again, just be familiar with the different possible operations required of you. So subtraction, division, multiplication are involved in these 4 parts, so you're going to want to remember some of your strategies, like, as mentioned before, lowest common denominator. And again, with those ones, we want to make sure we're comfortable with numerical calculations so you don't get stumbled up on some of the arithmetic when you're solving problems in Chapter 6. For number 9, you may want to pause at this point and just try to remember what you've done in grade 9 and 10 to build your base of understanding. So for finite differences, there's a couple principles at play here. The finite differences are related to the degree of the relation. So if we're looking at a linear relation, we would expect to see constant first differences. First difference is exactly what that means is, I often think of it as the change in value. So for example, the change in y specifically, we're looking at making sure that x is increasing by a constant amount. That's really important when we're evaluating first differences. And if that's true, and it is, then we can simply subtract first number from the second. So 24 subtract 44, and we're going to get negative 20. 10 subtract 24, we're going to get negative 14. Negative 8, negative 2, and 4. So clearly that is not a linear relation. So we want to pursue second differences, which just repeats the process where we're taking the differences in these values. And for quadratic relations, of course, you're looking at second degree. Those have the highest power of x being 2. Take the form ax squared plus bx plus c, typically in standard form. So an equation that might resemble that would have that general form. So quadratic relations have constant second differences. And so this question is targeting that property. If there's no pattern in the differences and we can't arrive at constant third or fourth differences and they just keep changing or repeating, we're going to conclude that it is neither linear or quadratic. And exponential equations, for example, have finite differences which will never be constant. Numbers 10 and 11, again, a little bit of repetition in number 10, so that one I'll leave with you. Finishing off with number 11 as our last example to look at for review. Solve each system of equations. We did look at this at the start of the year, but for some of you, it might have been a little challenging at that time, and there's been a lot of class in between then and now. So at this point, I would suggest going back to the prerequisite skills section, looking at either method, elimination, or substitution. And you have options here. Some of you indicated that you preferred the substitution method. It's a little bit more straightforward. In that case, what we're trying to do is isolate each equation, and it's a good idea to just label them, equation 1, equation 2. Equation 1 is already isolated in terms of y, so we want to do the same thing for equation 2. I'm thinking there of rearranging that, so I would subtract 3 from both sides, and I would add y to both sides. So just run that through, make sure that those two operations are your choice as well, and I think you would arrive at x subtract 3 equals y. I'm not showing the in-between steps here, but what I'm trying to get at is in both cases I now have an equation in terms of y, and we're going to set those equal to each other, and that's only true when we're at the point of intersection, which of course is what it means to solve each system of equations. You'll notice in the other examples here, neither of these four equations have y or x isolated, and so it might be more appropriate to perhaps choose the elimination method. However, you need to find a strategy that works best for you. In this case, graphing technology could also help. However, we would still need to have our equations in y equals form in order to use the equation editor for the graphing calculator. So at this point, going back to our first line here, we have a simple task of isolating x. I would subtract x from both sides, deciding to isolate my x's on the left side, and I would add 5 to both sides. And then that's going to produce my variable term 2x on the left side, my number 2 on the right side. That means x equals 1. Pretty confident of that. At that point, I would solve for the other coordinate. And I have two options, so I can go back to either equation 1 or equation 2. And I think I'm going to choose equation 2 because it's nice and easy to work with. So I'm going to substitute x, which is the value 1. I'm going to subtract 3. I'm going to get negative 2. At that point, I think my point of intersection is 1, negative 2. I would want to just finish off by checking, and I think there I would have to go back and check in the other equation, which would be equation 1. Make sure a check is always set up left side, right side. Going back, the left side of the equation is 3x subtract 5. The right side is y. I think it's important to write that out as a first step, and then substitute the values in. X is 1. I would be left with negative 2. Y is negative 2. Left side equals right side. That's what I wanted to see. That means that the point of intersection, which is the solution, is 1 for x, negative 2 for y. And we can confirm that if we were to graph this system, either on graph paper or graphing calculator. So I leave those questions with you, and you fill in more parts as your need arises, and see me in class if you need any help. Good luck.